All right, guys. So this is like it's been like a day and a half since I did the drives. I ended up putting all 5 drives in. They all fit in the lower area, kind of closer to the fan, and everything worked perfectly. I booted it up and plugged everything and booted up, and there's no problems whatsoever. pfSense booted up just fine. The drives were all recognized. I formatted them all. So basically, I created my Z pool just with the raw devices because I prefer to do it that way, so it gets the full space instead of using partitions. And everything worked fine. Now, what you do want to do for maximum performance with those kind of drives, with most hard drives nowadays, they're 4K formatted. Older drives used to be 512-bit formatted, but now they're 4K formatted. So to get higher performance, you actually want the file system to also know that it's 4K formatted, so it creates its blocks in chunks of 4K instead of having to do individual little ones when it doesn't erase. It just does the full block amount, so it knows about that. To do that in FreeBSD, you have to kind of play around a bit for ZFS. You need to create NOP devices. NOP with spelled GNOP. If you look it up online, you'll find instructions to do so. The basics are you just create a NOP device for you have all your devices in there, right? /dev ADA1 through 5 was the devices I had. Um, and what I did was I just did the NOP create command with the flag. I believe it's dash capital S and then space 4096, so it's 4K aligned. So basically, it creates a bunch of fake devices that talk to the actual block, and then you create a block device, and then you create your Z pool with those 5 NOP devices. And now the Z pool will then have the A shift value of 12, which means 4K. It's I think 4096 is 2 to the 12th power. I'm assuming, yeah. So so now your Z pool is 4K aligned, and then you end up exporting your Z pool. You then destroy all the NOP devices, and then you import your Z pool again, and now it uses the raw devices because the Z pool information is still on the raw device, and your Z pool is now created with the 4K. So you have to do a couple extra steps to make sure it's 4K aligned, and that's just because drives nowadays are 4K aligned, but they still tailor the operating system to 512 aligned, and that's for compatibility with really old OSs. I think like possibly Windows 2000 or XP don't work with 4K, so they and just by legacy, those drives still do that. They still say they're 512, which will lower performance on your Z pool. So do that NOP thing. If you are doing on pfSense, it's kind of tough because you don't have the NOP binary or the NOP module in the kernel. They remove both of those. So get those. I just downloaded the FreeBSD 8.3 ISO. I went to I mounted it and mounted it, and then just searched around for the /sbin /NOP. So I just pulled the binary from there, and I pulled the module from probably /boot /kernel, and the module is in there. It's called GEOM underscore NOP GNOP.ko. So that's like a module file for FreeBSD, and it's in part of the kernel, I believe. So I took those 2 files. I put the module file in pfSense /boot /modules directory. You just put the co file in there. You have to change its permissions to 555, which is readable and executable but not writable. So do that, and then do your KLD load command. So KLD load, and then put the GEOM underscore GNOP. You don't have to put .co. It knows it's a .co file in the boot /modules directory. So just load that module, and then you only need it temporarily, and then use the binary, put that in SBin, and then do all your NOP commands you need to do. And then afterwards, I just unloaded it, KLD unload, and then GEOM underscore GNOP. So you can unload the module later, and then you can delete the binary if you don't want it anymore. Just dirtying up your system. So I did that. So now I have a Z pool that's 4K aligned, so it's maximum performance there. And then I created a data set on there, media. Oh, when I import it again, most of you will probably not want to just mount it straight on wherever the Z pool's name is. So mine is named Tank, just to keep with the Solaris, the default way Solaris had it. But I mounted it on /mount /tank. So when you do Z pool import, you do Z pool import dash capital R and then space and then /MNT. So now it knows the root place to mount it on is /mount. So then it mounted it on /mount /tank. So now that's where my Z pool resides. And then you don't even have to do an FS tab or anything, which is kind of nice. You just mount it, and now I think as long as you have ZFS running, the Z pool itself will save where it was mounted and that it was mounted on that operating system. So it's kind of cool. You just need to make sure ZFS is enabled on your FreeBSD or pfSense system, and it'll automatically mount whatever mount points are normally mounted. So yeah, I did that, and then I'm putting back all the files that were on the old 3-drive RAID Z. Now I'm moving them onto my 5-drive RAID Z, where I temporarily back them all up to my FreeNAS box. My FreeNAS box isn't in full production at my house yet, so I had it at my sister's house. I copied all the 4.6 terabytes off of it, and I used rsync, and now I'm copying them all back onto it. And you can see it's running right now in a tmux shell. So even if this, I close this terminal, it just keeps running, because this operation of copying all back on is going to take 30 hours total. It's almost done now since it's been a few days. But what's it called? Yeah, so I copied them all off. I'm copying back all on. Now the speed is somewhat limited, as you can tell. You can see I'm only getting around 40. I used to be getting around 41 megabytes per second for each file. As you can see, most of these files are going around 40, right around there. And I've done some looking into it before. It's just because of the CPU on my sister's pfSense box. It's an E350 low power AMD CPU with a built-in GPU. It's not the best thing CPU wise, and that's why it can't really push that much data through its NICs. It is pushing through a PCIe Intel NIC, but it still can only push so much data. And I've actually tested this before. My FreeNAS box, that used to be the CPU in my FreeNAS box, but I changed it out to a different motherboard and CPU. I changed it out to a G530, which is an Sandy Bridge Intel Celeron Pentium processor, I think. No, is it? Yeah, Celeron processor. Sorry, it's a Celeron from the Sandy Bridge series, G530. It's around 2.5 times the amount of CPU as this current system right here. So actually, it's not using much CPU on my FreeNAS side, but it's maxing like 70 to 80% on the pfSense side, and that's just the max the NICs can handle. And if you check top, like most of it is just using interrupts is what's taking the CPU right now. So that kind of sucks that you can't actually push a full gigabit. A full gigabit would be 120 megabytes per second, so I'm going about a third of a gigabit. So my other thought was originally to do this thing faster was to take all of the 5 drives and plug them into my FreeNAS machine, so I'd end up having like my 10 drive array in my FreeNAS machine plus these 5 drives. So I would have needed 15 drives of space of connections, and I could have added an extra RAID card and had that, but I would have also needed the power, which means I would have had to take the power supply out of one of my other computers, and it would have just been a hassle. So I ended up just thinking I'll just do it over the network, because I'm back home for the whole weekend. So I started it like around 2:30 a.m. on Saturday morning, and it's now Sunday morning, and you can see it's almost done. We're already on TV shows. It moved all the movies. It's now on TV shows, and it's on The Voice. So we're down to the T's. It's pretty close to being done. Let me see. Let me just do this. You can see right here, there's about 4.6 terabytes on there, and it needs to go to 5 terabytes, because that's how much I have on my FreeNAS machine that I'm copying back over here. So then she's actually going to have more movies than she originally had, because I had some on my FreeNAS machine she didn't have on her pfSense box. So her pfSense box will then end up having 5 terabytes out of, this is actually 10.6, but they don't show 3 digits if they have a period. So I think there's around 10.6, 10.7 terabytes of space now on my sister's system usable, and that's with 1 drive of redundancy. And yeah, so what other things could I talk about is let me talk about the rsync. So I'm doing it over rsync. My other thought was originally, because I'm moving from one ZFS to another, is using ZFS send and ZFS receive, because it'll send the direct blocks instead of the actual files, which actually would be a little bit more efficient. The problem with that was I don't have much experience with it, but also I'm sending it from a FreeNAS 9.1 box, which has ZFS version 5000, and I'm sending it to a pfSense 2.1 box, which has FreeBSD 8.3, which has ZFS version 28. So version 28 can't receive 5000. You can't usually ZFS receive from a higher version. Now with version 5000 and above, I think they can send to each other, but sometimes there are, because now the versions aren't changing, they're going to stay at 5000. They're just going to have feature flags, so your ZFS system could have more features than another one. So depending on what feature flags were enabled, your data sets can or can't move over to another system. So there was some, it's not actual backwards compatibility because we're trying to get an older system to receive a newer data set. It's actually called forward. It would actually have been forward compatibility if you can have an older like kernel be able to accept a newer file system version, and it can't. Obviously forward compatibility is rarely an option. Like you can't stick a DVD into a VHS player. Sometimes you can put like you have a DVD plus VHS and you could put a VHS in there. That's backwards compatibility, but or that's like putting a PS3 game in a PS2. It's obviously not going to work. But they're trying to work on that with these feature flags. So maybe like if you enable one feature, if it's not enabled on one of your other data sets, your other data set didn't have that feature enabled, it might be able to still go onto an old another ZFS system, version 5000 ZFS system without that feature flag. So that might actually be an option in the future, is those feature flags. Also, some features might not make it writable, but it'll still be readable. So there's different things coming up with ZFS now that it's a little more open. So yeah, I talked about the speed, network, rsync flags. Oh yeah. So I'm actually just using rsync, the good old program that I use a lot whenever I'm moving files. And here's some of my, I don't know if you can, yeah, you can kind of see that. It's kind of bright. rsync-r, that just means recursively in the folders. Size only, that's because normally rsync will look at the file stamp and the size, the timestamp to see if it's changed, and I don't care about the timestamp. Like, these are large 10 gig video files. If it changed at all, it's probably going to be a larger size. -w, that means if the file changed, that means if the file didn't change size, or if the file did change, what it'll do is it'll end up checksumming the file and each like parts of the file and try to see what part of it changed. And that's helpful if like you have a document only part of it changed, but that's not helpful when you have like a large video file and it's different. So it's a waste of time. There's no point in checksumming the file, which just takes CPU time. I just want the whole file to be sent over. So that's what -w does. And -w is good when you have a slow network with high CPU. So say you have two servers and separate parts of the country sending files. You don't want -w. You want just the default checksumming. It uses some diff algorithm, but when you have a fast network, like on a LAN with slower CPUs, like me, I have one slower server, then use -w. -- progress just shows all the progress you can see that you could see on the earlier screen. That's the IP, of one of the boxes, and then you see the : : You can barely see it, but that just means I'm using the rsync daemon instead of using, it over SSH, would have been way slower because it would have taken more CPU. But anyway, that's it. This is almost moved over, and then my sister's system will finally, I think, be complete. It'll have a full 5 drives in there. It's taking up every port, even the eSATA port. So basically, at this point, there's no upgrades. I'm just going to let it sit there for the rest of my life and just let it run. Yeah, hope you guys enjoyed this series of projects, and I'll see you guys later.